Hi, this is a video lesson to explain the idea of Unit 6 in trigonometry, and the idea of this very short unit is to solve trig equations. So understand that when you have an expression such as 2x plus 3y, you can't solve that. There are variables in that equation, in that statement, but there isn't an equal sign. It's not an equation. So we can't solve it because there is no equal sign. Also, a statement such as this does have an equal sign, but that doesn't have one particular solution. It has many solutions, right? 5 plus 0 is equal to 5, which makes 5 a solution. 11 plus 0 equals 11, so 11 is a solution. This is a statement which we would call an identity because it's true for any value of the variable. And then the last statement is actually the kind of equation that you would typically think of solving. It's not an identity, so it's not true for every value of x, but there is a value of x for which this statement is true. We would find that value by doing some algebra, right? Subtracting a 7 from both sides, for instance, would give us this. And adding 8x to both sides would give us 10x equals negative 20. And so x would equal negative 2. This statement is what is called a conditional equation because it's true only under the condition that x equals negative 2. That is the condition. So the first statement, which I had put a blue box around, is an example of an expression, not an equation. The second example is an example of an identity. That is something that is true for all values of the variable. And then the third thing is what's called a conditional equation. Now in the previous unit, in Unit 5, we worked a lot on identities, right? We spent tons and tons of time using things like this, sine squared plus cosine squared equals 1, and simplifying different trig identities using things from our formula card, okay, as well as variable. As well as algebra, I meant to say. So we used algebra and we used formulas from our card of trig identities, and we reorganized things. This unit is going to be about solving trig equations. Anytime we're solving an equation, the goal is to isolate the variable. So that will be what we're always trying to do. We're trying to get the variable alone. In solving equations that involve trig functions, the step right before having x by itself will be to have a trig function of x or a trig function of theta by itself. For all of the problems we're going to do, we're just going to solve on the interval from 0 to 2 pi. So you might realize as we're working that there are going to be an infinite number of answers in some cases, but we just need to give the answers between 0 and 2 pi. In looking at these examples, if you are a little weak on your unit circle understanding, it will be useful to have a unit circle handy. So if you want to pause the video and get your unit circle out, that would be a good choice. All right, here's our first example. Okay, so in your notes sheet, I've written to you this exact same problem. Solve the equation 2 sine x equals 1. Remember that we want to isolate the variable, and right before that, we're going to isolate the trig function. The thing that is keeping company with this trig function is this multiplying by 2. So to undo the multiplying by 2, we're going to divide both sides of the equation by 2. These 2's make a 1, and so in my next line of work, I just have sine of x equals a half. And then I need to ask myself, well, where in the world between 0 and 2 pi is sine equal to a half? So if we go back to our unit circle, remember on the unit circle, everything is cosine comma sine for those ordered pairs. I want to know where sine equals 1/2. So I want to know where the second number has a 1/2. If I scan around, I see that here and here. So the two angles I want are pi over 6 and 5 pi over 6. Those are my solutions. And sometimes students have a difficult time with the idea that a question can have more than one answer. If I were to ask you, where would you like to go on Friday night? And if I'm one of your friends and I ask you, where do you want to go on Friday night? You probably have more than one answer to that. If I go home and my husband says, I want to make dinner for you, what would you like to eat? I have more than one answer to that because, if someone's going to cook for me, I have a lot of flexibility in that. So questions can, in fact, have more than one answer. A way to conceptualize what we just did in this question would also be to draw the sine curve. Okay, and what I mean by also is you could look at the unit circle, you could also think about the sine curve. Here's our sine curve. We know that the top of the hill is at 1. Therefore, 1/2, which was the value we had here, is about here. And see how there's 2 spots where that line crosses the sine curve? This location is pi over 6. This location is 5 pi over 6. Just another way to think about it, in case you want another way. The next question has tangent squared equals 3. So we want to get tangent of x alone, so the thing we need to get rid of is the square. My first line of work would have the original equation, and then I'm going to square root both sides. Okay, I choose that because squares and square roots cancel each other out, leaving me with just tangent of x. Now, if you take the square root of something that contains a variable squared, the other side of your equation needs to be either positive or can be either positive or negative. So we have tangent of x equals plus or minus root 3. If you look back to your unit circle, the family that has a tangent of root 3 is the 60-degree family. And so the angles in that family are pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. All of those either have a tangent value equal to positive root 3 or negative root 3. So those are the 4 angles that are my solution. So this particular question doesn't just have 2 answers. It has 4 answers. You can see that this unit is a good one for reviewing your unit circle if that's gotten a little weak in your memory. A good thing to have happen before our final. Okay? Example 3 has this problem. Now, if this question were x squared minus 1 equals 0, think about how you'd solve that. You would move the 1 to the other side, and then what? Hopefully you said take the square root of both sides. Okay, that's the same idea as what we're going to do here. We'll move that 1 to the other side by adding 1 to both sides of the equation. And then, in my next line of work, I need to get rid of that square. And the way to do that is to take the square root of both sides. This side, the square and the square root cancel each other out. And when I take the square root of a variable squared, the other side is going to gain a plus or a minus, and the square root of 1 is 1. So, this is sort of awkward to think about, secant. So it might be easier for you to say, well, secant is 1 over cosine, and the whole number 1 is 1 over 1. Okay, so I'm just changing that left side to be, secant is 1 over cos. And then here you could say, well, if I were to cross multiply, I'd get that the cosine of x equals plus or minus 1. Or you could think of, take the reciprocal of the left side and the reciprocal of the right side. Ooh, that might even be easier to think about, to take the reciprocal of both sides. So now I'm looking for where cosine is 1 or negative 1 on this unit circle. So let's check that out. Cosine is the first number on the ordered pair. So here's an ordered pair where cosine is 1. Here's an ordered pair where cosine is negative 1. So I'm going to go back to my question and say that the 2 values of x are 0 and pi. Okay, the 2 places where cosine is equal to 1 or negative 1 are 0 and pi. Okay, 3 more examples to go. Example 4, ooh, this looks a little bit dicey. The directions say to solve, which means get x by itself, and I have more than one trig function, and I have stuff on both sides. So it might be tempting to divide by cosecant of x, and I would encourage you not to do that. Anytime you have a variable You do not want to divide by the variable. It causes solutions to evaporate from your problem. So what I did was I just subtracted 2 cosecant x. I moved this term over to that side using subtraction. Now, this is actually a factoring question. It's in the form it is not in that form. It's in the form AB minus 2B. Okay, if you put in A's and B's. So A is like secant, B is like cosecant. If you look at this, you should be able to see that it has a greatest common factor. Okay, and that is certainly true of our problem as well. It has a greatest common factor. Can you tell me what that greatest common factor is? Cosecant. So factor out cosecant. What's left from this first term? Secant. What's left from this term? Minus 2. So that is what I would do as my first step after you move that one term over to the other side. I would do some factoring. Then the point of factoring is if you factor with something set equal to 0, then each of the factors could equal 0. Either cosecant of x equals 0 or secant of x minus 2 equals 0. If the second one is true, I'd get secant of x equals 2. Now use the idea of what secant is. Secant is the reciprocal of cosine. So take the reciprocal of both sides. The reciprocal of secant is cosine. The reciprocal of 2 is a half. So I want the angles whose cosine is a half. Look back. Which angles have a cosine of a half? Find 2 answers. My 2 answers off the unit circle were pi over 3 and 5 pi over 3. Now this other equation over here says cosecant equals 0. If you were to use this move of take the reciprocal of both sides, this part would be sine. The reciprocal of 0 would be 1 divided by 0. We can't do that. Not defined. No can do. So this part has no solutions. Okay? There is no place that cosecant equals 0. Think about the cosecant function. When we graph cosecant, remember how you get these smiley faces and frowny faces? Cosecant set equal to 0 would mean where does this curve intersect the x-axis where y equals 0? It doesn't. Please don't touch. There's this big space in the middle. No solution. Okay, the next one is in the form of a factoring problem, like a quadratic. It's in the same form as 2x squared plus 3x plus 1 equals 0. How would you do this side problem? Hopefully you can factor that. 2x squared is 2x and an x. The 1 in the back makes a 1 and a 1. And if you think about the signs for doing FOIL, this would have to be plus and plus in order to get 3x right there. So in our problem, the only difference is that instead of having plain x's, we have sine. So this first factor would be 2 sine x. Plus 1, I'm just using that factor from down here. And then the other factor would be sine of x plus 1. Okay, now the whole point of factoring is so you can set things equal to 0. So here we have our factored form set equal to 0. So this implies that either 2 sine x plus 1 equals 0 or sine x plus 1 equals 0. One of those has to be true. If this left side equation is true, you subtract the 1 and divide by 2. And you get sine of x equals negative a half. Unit circle time. Where is sine equal to negative a half? So those are our values, 7 pi over 6 and 11 pi over 6. And on this part, we'd get the sine of x equals negative a half. So I want to know where sine is negative 1. That would would be here, and that angle is 3 pi over 2. So overall, this question has 1, 2, 3 solutions. All 3 of those are answers to our original question. The last example is this guy. And this one is complicated in the sense that we have sine and cosine in the problem. We also have a squared term and a non-squared term. So I would begin with just writing the left side as it is. And then here where you see cosine squared, use a trig identity. Cosine squared is 1 minus sine squared. This makes an improvement to the problem because now everything is in terms of sine. Let's distribute. And then let's move these 2 terms that are on the right, let's move them to the left side of the equation by adding them or subtracting them depending. So add 2 sine squared to both sides. And then keep this sign, and then a 1 on this side and a 2 on that side. It would be 1, take away the 2. Okay, so if you just move all the terms to the left side and kind of clean up, you should get this equation. This is a factoring problem. It's just like having 2x squared plus x minus 1 equals 0. If you think of how that factors, you need a 2x and an x. You need a 1 and a 1. You need the middle term to be positive 1 and the back term to be negative 1. And that should do it. That's the factored form. So I'm going to use that information in my actual question up above. So my 2 factors are 2 sine x minus 1 and sine x plus 1. And once I have factored form set equal to 0, that means one of the factors has to be 0. If the first factor is 0, that would mean sine of x is a half. If the second factor is 0, that means sine of x equals negative 1. So you need to go back to your unit circle and find out where sine is equal to a half, which is here and here. And you need to find out where sine is negative 1. Oh, that was like the last question had that as well. So my solutions on this last question on this part would be pi over 6 and 5 pi over 6. And over here, 3 pi over 2. So that question has 3 solutions. I hope that this is clear to you, and if not, we will work more on it in class, so do not despair. Do bring your notes to class to help you out, and I will see you at school.